In this video, we'll learn how to integrate 3D geometries onto HDR environments or photographic backplates using a combination of dome light and the available matte options in the Redshift object tag. To integrate your 3D models to a photographic plate, you need a backplate or a photographic plate and a matching HDRI for that plate. I have included a photo and its matching HDRI thanks to HDRI Haven, a great resource for free HDRIs and backplates. So first, let's add a Redshift dome light. And load this Skylit Garage HDRI image. Now we can open up the render view and start IPR. We can hide the ground plane for now so we can see the HDRI a bit better. And as we are in ACES and this is an HDRI image, we need to change the color space to Scene Linear Rec 709 sRGB, as we learned. And now we need to rotate the HDRI image to match it with the backplate so the lighting will be consistent. Let's flip the dome light horizontally and set the heading rotation to around 75 degrees. Now it matches with the photographic backplate. We don't need to see the HDRI image, we just want to see its contribution to the lighting and instead see the backplate photo in the background. So let's come down to the backplate section of the dome light and load the backplate photo that comes with this HDRI. The next step would be to match the camera with the photo. I've already done that. You can just move it around until it matches or use tools like Cinema 4D's camera calibrator tag to match the camera perfectly. Let's make our ground plane visible again. You notice it has a default Redshift material and the dome light casts the shadow of the car on it. We basically want to hide the ground plane but keep the shadows it catches from the car. So we just want it to be a shadow catcher basically. For that, let's add a Redshift object tag to the ground plane. Go to the Matte tab. Now check this override and enabled under the general section. Now the ground plane is turned into a matte object, that is why it is no longer visible in the render. If I want to turn it into a shadow catcher, we just have to check this enabled option under the shadow section and that's it. And voila, the car is integrated into the photo. Now let's take a look at some of the more important options here. First, we have this show background. When this option is enabled, we can see the defined background image in the matte object place. Otherwise, the matte object will be black. If I unhide this sphere object that has a very reflective material, you notice the reflective sphere does not know that the ground plane is turned into a matte object and still reflects its original material. To make it aware, we just need to enable this apply to secondary rays checkbox and that solves the issue. When this option is checked, it enables the matte object override for secondary rays such as reflections, refractions, and global illumination. Down here in the shadow section, we control how the shadows look. We can change the color of the shadow and its transparency. And we can basically use these two options to tint the color of the shadows to match a photographic backplate or to match the shadows in a photographic backplate. We can maybe steal the shadow color using this color picker from underneath this car, or maybe from here. If I check the alpha channel right now in the render view, we get a solid white color. When this affect alpha option is enabled, the intensity of the matte shadows will be stored in the alpha channel and the alpha channel would contain the shadow mask. For now, let's disable it. We also have this alpha contribution scale up here. By default, it is set to 1 and therefore the matte object will contribute to the alpha channel. And when set to 0, it does not. For now, let's set it to 1. And then we have this reflection, refraction, and diffuse contribution amounts, which scales the amount of reflection, refraction, and diffuse or global illumination visible from the underlying materials that have been overridden. In this case, we know we have applied a default redshift material to our ground plane, which has some reflections, but the reflection of the car is not visible on the ground plane. If I increase the reflection scale to 1, we start to see some reflections as well. To see it more easily, let's select the material and increase its IOR to around 5. And now the car's reflection is more visible on the ground. Maybe we can adjust the roughness a bit. When the road is slippery and wet, it's nice to have some reflections. For now, set the reflection scale back to 0. Now, if I change the diffuse color of the ground plane material to something like an electric pink, and check out the global illumination pass, you notice the material does not affect the indirect lighting at all. But when I start increasing the diffuse scale, you notice both in the beauty pass and in the GI pass how the material applied to our matte object contributes to the GI as well. For now, let's set the diffuse scale back to 0 and change the ground plane material diffuse color to its default mid-gray color. One last thing I want to talk about is this affected by matte lights option. If I turn on this pink disk area light in this extra light group, you notice it casts its shadows and the ground plane catches the shadows. But what if we want this light source to actually illuminate the matte object, which is our ground plane? First, we need to come to the object tag and enable this affected by matte lights option. And also make sure the diffuse scale for the object is more than 0. Let's set it to 1. Then we need to select the light source and in its details tab enable this matte shadow illuminator. When we do that, the light is no longer casting any shadow on the matte object because the matte surface is expected to be actually illuminated by this light when this option is enabled. And when we enable this affected by matte light option for the matte object and increase the diffuse scale as well, these two options allow the matte surface to be illuminated by the matte shadow illuminator light. For now, let's hide this pink light and make sure the sphere is hidden as well. Now let me show you a more practical example. I'm going to turn on these headlights for the car. You notice when the matte shadow illuminator option is disabled for the headlights, they don't illuminate the matte surface. But the moment we check matte shadow illuminator, the headlights illuminate the surface as they should. Okay, that's enough for now. In this video, we learned how to integrate 3D geometries onto HDRI environments or photographic backplates using a combination of dome light and available matte options in the Redshift object tag. See you in the next one.